In this video, we're going to look at financial concepts, including compound interest, annuities, inflation, and amortization, and how the GDC can help us work those out. Now, compound interest is a bit more complicated than what you might have seen before. We'll start off with a familiar-looking example, and then we'll try and add in some more realistic aspects to it, which will make you see that this rather simplistic way of seeing it isn't really how the real world works. So in this example, somebody's got 5,000 of the currency. In the example we're working with, it's Brazilian real, doesn't really matter though, and they're getting 2.5% interest every year for 5 years, and that's the amount of money they get after that. So that's a very familiar calculation. First thing we've got to do is break this down into separate parts. So we got the 5,000, that's our present value. And this here is another way of writing the percentage multiplier, but we're doing it as a fraction. Now this is very useful because what we're going to do now is we're going to take this 2.5% annual interest rate, and we're going to do what banks actually do in real life, which is pay that interest, or if it's a loan, charge that interest monthly rather than yearly. So they still want to achieve a 2.5% annual rate, but they want to apply that interest every month rather than every year. That's what banks actually do in reality. They don't, if you've got a loan, they don't charge you a big load of interest right at the end of the year. They do smaller amounts every single month. Same if you've got a bank account, they'll actually work out your interest every month rather than just at the end of the year, which does make more sense because people don't tend to want to wait around a year before making any payments or receiving any payments. So the way to do this is by taking this 2.5% as a fraction, so 2.5 over 100. And if we want to divide this into months, we're going to divide it into 12. So we divide by 12. But another way of saying that is multiply by 1 over 12. And if we actually do that calculation, we see that it becomes 2.5 over 100 times 12. And you can work that out, but I'll keep it like that just to show what's happening here. So if we want to do this calculation but monthly, we're going to change this denominator here to 100 times, in this case, 12. We also have another problem now, which is that if we're trying to do this monthly, this 5 no longer is correct, because that's now saying that we're going to apply this interest rate just 5 times. But this interest rate is now 1/12 of what it was. So we need to apply it 12 times more. So in fact, we're going to get 60 applications of this interest rate, which is the same as doing every month for 5 years, which is what's happening. So you need to also times by 12 in the power. Now what we've just worked out actually is the second question from the examples in the notes, number example 7(1)(b). And in that question, we'll just quickly look at this. The initial question is he starts with 5,000, gets 2.5% for 5 years. That's the initial question there. But in the next one, he puts that money into an account that does 2.5% for 3 years, but it does compounding monthly. So I'm just going to change the calculation slightly here. I'm going to put this amount that he gets from the first account here. So this is our new starting value, or present value as we're going to call it in this video, and he's actually doing it for 5 years this time, so we're going to change the 5, sorry, for 3 years, we change the 5 to a 3. Okay, so this is now how you would work out the second problem on the examples. That's not too bad, but what we're actually going to do for most of these problems is use the GDC to do the same job, because it has a bunch of features which are going to be extremely useful when we start looking at more complicated problems. So let's have a look at that now. Go to the menu, and if you then go to this TVM section there, you've got to scroll down a bit to see that. This is the finance application of the GDC, and you get all these different things here. We're going to look at these a little bit later, some of them, but we want compound interest in this particular case. And in this case, we're going to be doing the second part of the question. So if we read through it again, just to familiarize ourselves, we've got someone starting with 5,657.04 real, That's his starting value. And he's getting 2.5% annual interest, but it's been compounded monthly. How much is he going to get? So the way we put that into the calculator is like this. In this case, the n is going to be 3 for 3 years. There's a few situations later where that's not going to be so obvious, but in this case, there it is. Interest rate is 2.5. Now, it's percentage, you'll notice here, so you don't put in the decimal, you're not going to put 0.025, you just put it in as a percentage. The calculator will do the rest of that for you. This is the bit that is initially very confusing. The PV, which stands for present value, we're putting in as negative, in this case 5657.04. So that's the money we're starting with. So let's go back to the formula here. That's this. Now negative, that doesn't make sense straight away because he hasn't lost any money. But this PV and this FV are best thought of as cash flows in opposite directions. And this isn't a convention that accountants use, and that's why the GDC is programmed this way. But initially it is a bit confusing. So the first thing to get is that PV and FV, the present value and the future value, these are always going to be in opposite directions. So if you put in a negative present value, immediately the future value is going to be positive. The way to think about it is if he's getting interest on a bank account, initially he's actually giving away 5,657 real because he's given it to the bank. So his initial situation is indeed that he has lost this money because he's given it away to the bank. But because the situation is that he's going to be receiving money back in the end, the future value is immediately going to be positive. In fact, let me just show you what would happen if we did 1 year of no interest at all. So the present value is this money here. It's in there for 1 year. He's not getting any interest. And if we then calculate the future value by pressing F5, see that FV there, it comes out as positive. That means that he's going to end up with a positive amount of 5,657, which is what you'd expect if there was no interest being paid and it was there for a year. You have to let that sink in for a second. I appreciate that it's a little bit confusing, but maybe if we see more problems, it will start to make a bit more sense. More examples will illuminate it, hopefully. Let's actually try and do the problem itself. So he's in there for 3 years. He's got 2.5% interest. These other options, we're going to deal with these in a second. What we do need to do, though, is scroll down here to this CY. That's compounding units per year. So that's the 12 I was talking about earlier. That means we're going to be dividing the interest, this thing here, into 12 bits per year. So once you put that in there, now we're going to calculate the future value. You'll notice the future value is still just what it was before. It doesn't update unless you press the button you actually want to calculate. So I'm going to press that now, and there we go. 6,097.16 is going to be. And that's the right answer. So we've used the GDC there to calculate a compound interest question with a compounding rate of 12 per year. All right, so we'll have a look at a few other problems as well involving the same option menu. Let's just quickly review the terminology here. So PV is present value, FV is future value, R is the interest rate, which is usually an annual interest rate. K is the compounding frequency, so in that case it was 12 because it was 12 per year. N is usually the number of years, and in the general compound interest formula that you get in the formula booklet, which is this one here, the N does stand for number of years. So that's why it's like, in this case, 3 times 12 would be 3 years, 12 times. But that's only true in situations where the interest rate is given annually. Now we'll look at a few other examples of this now, but that's a good start. Right, so that's example 7, and I'll let you have a look at that in more detail. I do recommend working it through yourself from the examples and making sure you can get the same kind of answer as me. Let's look at example 7, because here's where the GDC application is quite valuable, because we're going to do a more complicated situation here. So this person, Zoe, is depositing 25,000 euros in a bank account. Okay, that's great. 2.4% annual interest. We're happy with that. compounded quarterly, which means she's getting the interest 4 times a year, so every 3 months in this case. So far, this is pretty straightforward. In fact, we can start putting this in the calculator, I think, as we did before. So let's go into there. She's got interest rate of 2.4%. That's easy. Present value, well, she's putting this into the account, so we're going to make this 25,000 but negative because she's given that money to the bank. She's compounding this quarterly, so we go back down to here, and this is not going to be divided by 12 this time, but divided by 4. And now in this question, if it was say asking, okay, how much money is she going to get after 3 years? Well, we just keep n as 3 and we calculate the future value. However, that's not what's being asked. Let's read the question in its entirety. So from this account, she wishes to pay her rent, which is €600 a month. Find how long it will take until the account can no longer be used to pay the rent. Right. So we have another option on the GDC, which is this PMT. Now this stands for periodic money transfer, not monthly, periodic money transfer. So this is something that is always subtracted from the future value. It might be worth making a note of this somewhere. It doesn't actually say this in the book, but PMT is always subtracted from the future value. So initially, her future value is going to be positive, isn't it? Because she's given the money to the bank, but the future value means it's coming back in. She's getting this quite nice rate of interest of 2.4. She's getting it every quarter, so that's going to be increasing. But she's also losing 600 per month for the rent. So this PMT needs to be put in as 600, and that's automatically subtracted from that future value. Now there's one other option we need to do here, which is this P/Y. This is saying how many periods there are per year, and this relates to the PMT. So she's paying this rent every month. That means that there are going to be 12 of these payments in a year, so we need to put this as 12. The GDC has this habit of immediately changing other options when you do this sort of thing, which you'll remember from the graphing software. Not very convenient. We want to make sure this C/Y is 4, okay, but it might automatically change it back. Well, I'll quickly review this. So we've got starting off as 25,000 negative, interest rate is 2.4, PMT, she's putting out 600 there. Now the future value, in this case, the future value is going to go down to 0 because we're trying to work out how long it's going to take for the money to run out, basically. So she's getting in the interest, but she's losing the 600. So how long is it going to take until that bank account gets completely empty? So we know the future value in this question is 0, so I'm going to put that in. The thing we're trying to work out is the n. Now it's defaulted to 3 from the previous question, but actually that's not the answer. We need to do the n calculation button to work it out. And it comes out as 43.5. Now in this case, that means months. So you remember me mentioning and underlining in red there that the n means number of years? Not necessarily. It depends on the settings you've used here. Really, the n is talking about installments. So another little note that I've made, it's slightly rubbed off here, but hopefully you can read that. N means installments, really. And those installments are dependent on how you've interpreted the period thing here. So periods per year is 12. That means these n's really represent months in this case. So it'll be 43.5 months, or indeed 43 complete months that she's got left in that place. Okay, so there's one other question to look through really. I'm going to briefly mention inflation, which fortunately is not too complicated. So inflation is just the idea that currencies lose value over time. So the amount of money in the system increases, it inflates. Therefore, the amount of money you need to buy a certain thing will also increase. Therefore, the value of that is decreasing. So when you've got a situation like this where somebody is earning some interest, they've got 5.2% interest, that's great, but inflation is also running at 3.1%, you have to take that into account. The calculation is pretty simple. You just do the interest rate, subtract the inflation, and that's given in the formula here. So then your new interest rate is a real terms interest of 2.1. So it's just making sure that you adjust the interest rate accordingly depending on whether there's any inflation or not. So I'll let you read through that example yourself, but it uses the same formula, so hopefully it doesn't make it makes a fair amount of sense. And the other concepts we're looking at are annuities and amortization. This is a really important thing in finance. If you want to work in finance, you have to be really confident using these concepts here, particularly the amortization concept. So when you take a loan out, like a mortgage like I've got, they tell you how much you owe. So in my case, £210,000, what we borrowed. And they'll say, you're going to pay this back over 25 years, but you don't pay a percentage of the loan per year or per month, because then it would change every single month. So you go back to this compound interest question, and this is something that does happen with compound interest. You get this 2.5% rate every year, but it's 2.5% of a different amount every year. So the amount of interest you're getting is different every year. When you're paying back a loan, it's very inconvenient for that to be the case. You want to pay back a flat fee. So in my case, I pay £902 every single month, and that never changes. Month 1, pay £902. Month 2, pay £902. The last payment in like 20 years' time is going to be for £902. That is even though there's an interest on the mortgage of, in this case, 2.35%. So that's being applied, but they've managed to work out a single amount for me to pay every single month, which is going to be consistent. And that process is called amortization. Annuity is the same thing, but it's money that you get rather than you pay. We're going to look at an amortization example here. So we can actually do a lot of the same sort of maths here, but hopefully in a way that makes some sense. So this guy's receiving $5,000 from a loan, kind of like the mortgage example I was just talking about. He's got an annual interest rate of 7.5% compounded monthly. So he's paying that interest out. It's be repaid in monthly installments at the end of each month within a 5-year period. So we've got to work out what that monthly installment's going to be for him to pay this loan on time. So I'm going to try and work this out in a slightly different way to what's on here, just to kind of show you how that might work. So previously, I was talking about the PV being from the person's perspective. If they were putting money into a bank account, we'd say the PV was negative because they've lost that money in the present value and they're going to gain it back in the future. I'm going to do the same kind of concept here. So from Jack's point of view, he's getting a loan of 5,000. So I'm going to make the PV positive. Now in the example, they're doing it from the bank's point of view. You get the same answer either way. It'd be interesting to see them both working simultaneously. But I'm going to do it from Jack's point of view. So he has a present value of 5,000. That's good. So he's received 5,000. He's paying an interest of 7.5%. So, sorry, 7.5%. So I'll put that in, 7.5%. It's repaid in monthly installments at the end of each month within a 5-year period. Well, I'll tell you what, let's ignore the repayments for a second. Let's just get rid of that PMT completely. And let's just put that as 1 there. And let's say that he's compounding this monthly and he's getting 5 years. Okay, so the period is just going to be 1 per year. So that represents 5 years now. The interest is applied 12 times per year. If I press the future value button now, you see it comes out as this negative 7266. Now that means from his point of view, he's going to end up paying that money out from Jack's point of view, which makes sense because that's what he's doing in this loan. He's got the £5,000 now, but because of the interest, he's going to end up actually paying this amount. And that's why it's negative there. However, in this question, we're trying to work out how long it will take him to pay back this loan if he's paying in monthly installments. So what we want to do here is make the future value 0. So I'm going to change it to 0. So the future value is now 0 because the idea the loan is going to be balanced off. The PMT in this case, well, remember what I said before, the PMT is always subtracted from the future value. Now the future value in this case for him is a negative value. So we need to be taking money away from that. So we have to think about that when we interpret the answer to this. Now it says he's repaying it in monthly installments at the end of each month within a 5-year period. So his payments are going to be in blocks of 12. So I'm going to change that to 12. This is very important now because we're saying that he's doing 12 of these payments per year. He's not doing 5 of them. He's doing 60 of them. This N does not necessarily mean years, it means installments. So we're going to do 5 times 12, which is just going to come out as 60. But that's where it comes from. Okay, so future value 0. Compound interest is 12 times a year. Got the interest rate there. Okay, so we're now going to try and calculate this PMT. So it comes out as negative 100.18, or let's say 19 to round up. Now that means that his payment is $100.19. Because remember, the PMT is always subtracted from the future value. So if we've got a negative PMT, it's like that's being added to the future value, which in this case is the amount of money he's paying back. So you have to interpret it in context. The calculator doesn't really know what you're working out. It just does kind of these default calculations. But that's the answer. So I think that will make sense. I'll let you read the other part of the question as well and see if you can work out where those answers are coming from. But the best thing to do with these questions is just to have a go at them and see if you can get the correct answers using this calculator function. Please do ask if you're not sure about anything.